with her bio. In the meantime, the main slide is up on the screen. I'd just like to remind everyone to mute their mics as soon as they join, and we'll start in about 3 to 4 minutes' time. Thanks, everyone. Good evening, everyone. I'm going to start a little bit early today because I'm going to read Jules's uh, bio, and I also want to mention a little bit about methylation, which is something that I think that a lot of people who are trained in conventional medicine haven't known enough about. So, Julie Allen Rowland has an extensive background in health and wellness. Initially, she trained as a podiatrist and expanded her expertise by getting a bachelor's degree in psychology and communication. She is based in South Africa and runs a private practice that focuses on diabetic and arthritic patients. Her pursuit of knowledge didn't stop there. Julie furthered her studies in exercise science, health and nutrition, and functional medicine out of the USA. She has written 6 books on a number of issues, all the way through from diabetes through to mental health, and has developed a comprehensive understanding of functional medicine, which explores the interplay between genetics, nutrition, lifestyle, exercise, stress, and other lifestyle issues in relation to chronic non-communicable conditions such as heart disease, diabetes, cancer, and osteoporosis. Her subspecialties include pain management, detoxification, gut management, energy management, and hormone and sexual health. And passionate about the current state of healthcare, Julie believes much of our health status lies within our own control. She is dedicated to empowering individuals through education, enabling them to make informed health choices that enhance their life and vitality. And her courses are designed to simplify the vast amount of health information available, making it accessible and actionable for everyone. So thank you, Jules. I'm going to hand the mic over to you.
Thank you, Jackie, and thanks everybody for joining me. So tonight what we're going to look at is understanding the impact of lifestyle. Specifically, it's really the lifestyle genes and how they impact on cancer. So if, for the benefit of the recording, if you can just have a look at the disclaimer, this lecture is not intended to substitute for professional medical advice, and it's for informational purposes only. So the overview of how I'm going to structure my lecture, I'm just going to start with some lifestyle habits and their influence as cancer triggers. I'm going to just go one level deeper into cellular processes that influence the prevention of cancer and, of course, recovery of cancer. Then I'm going to have a look at, do a brief overview of genetics and epigenetics, and then I'll go into specific gene SNPs that influence cellular health, obviously related to cancer and the recovery of cancer. And then just to tie it all together, I'll give you a few practical examples of SNPs in action, and I'm going to look at methylation because, as Jackie said, methylation is really, really important. I'll explain a bit more about methylation, and then I'll use the gene SNPs just to look at breast cancer and detoxification. And then if I've got time at the end, I'll just mention gene profiling in South Africa. I don't know in Zimbabwe whether it's accessible in Zimbabwe, but that's maybe something to be explored. So what really I'm looking at, if you look at cancer treatment as a puzzle, gene profiling is really one piece of the puzzle to help you create a comprehensive profile and support for the patient. But of course, if you're going to be looking at gene profiling, one has to ask the question, and that is, if I'm going to look at gene profiling for my patient, is it going to affect the way I treat the patient? And is it going to benefit the patient? Or is it just another money drain that the patient has to pour money down where ultimately it's going to be of no great benefit to the patient in terms of treatment decisions? Now, when you have a look at lifestyle or lifestyle triggers for cancer, actually, the genes that are direct cancer genes only make up about 5 to 10% of the cancers. 90 to 95% of cancers are actually brought about by environmental concerns. So obviously the lifestyle concerns. So of course, if we're going to have a look at lifestyle issues, we need to ask the question, why would one person get cancer and maybe another person who's within the same household, maybe exposed to the same toxins, exposed to the same air, having the same lifestyle variables, why does one person get cancer and the other person doesn't? And it's actually all to do with the gene SNPs that we inherit. So because they're inherited, again, one can ask the question of, am I doomed by my genes? Or am I in a situation where knowing about my genes is going to help me prevent the increased risk of cancer? Can I be in a position where I'm hiding certain genes that I don't want expressed and expressing certain genes that I do want expressed? And understanding the gene profiles and understanding the SNPs that affect our lifestyle decisions is actually going to be helpful with regard to that. Now, the big picture of cancer, and perhaps one could call it the peripheral influences on whether we are likely to be of high risk in developing cancer or not, are as follows. So inflammation, we all know inflammation is almost a bedrock of cancer. Oxidative stress, we know oxidative stress influences our risks of cancer. Hormone detoxification, specifically when we're looking at breast cancers or the hormonal cancers, where we're looking at detoxing estrogen. Immune dysregulation, metabolic dysregulation, mitochondrial cytopathies, in other words, how healthy our mitochondria are. High iron risk. Detox capacity is a little bit of a given because we live in this soup actually of toxins. So whether our body is able to detox these toxins is obviously going to influence our risks of cancer or our recovery if we happen to get cancer. Methylation imbalance, which I'll go through in a little bit more detail. Stress. I think probably everybody who knows somebody who's had cancer, if they ask them the question is, what was your psychological state at that time? I would say almost everybody would say they were in a very stressed state. And vitamin D is a big player. And if we just dive down a little bit more, in terms of inflammation, inflammation drives angiogenesis. Inflammation, of course, brings all your pro-inflammatory cytokines, so your interleukin-6 and your NF-kappa B. It increases your reactive oxygen species, so that, of course, feeds into the oxidative stress. It increases growth factors, so, for example, VEGF. That, of course, influences your angiogenesis as well. And, of course, you've got your tumor-associated macrophages. In oxidative stress, we've got mitochondrial damage because our mitochondria, as I'm sure you all know, create their own reactive oxygen species. We've got DNA damage and membrane and protein oxidation and metabolic disorders. And I think, Jackie, you mentioned a couple of weeks ago that Paul Marek was looking at cancer as a metabolic condition. And in fact, Thomas Seyfried wrote a book called, I think it is called Cancer is a Metabolic Disease, which is very, very interesting. It's a little bit heavy going. And if you want a lighter read, I think there's one called Tripping Over the Truth, which looks at cancer as a metabolic disease and in a sort of a more readable form. But that's a factor now that we're looking at. Detox capacity, so our exposure to persistent organic pollutants, hormones, estrogen is a biggie, BPS, phthalates, heavy metals, and of course our chemotherapy agents and methylation, as I've mentioned. So when we're looking at addressing cancer, if we're looking at lifestyle issues, there's sort of like a scattergun approach, and there are pros and cons with both. So if we look at the scattergun approach versus, say, the gene profiling approach, the scattergun approach one can certainly do, but it might load an already overwhelmed patient. Also, the scattergun approach can be very time-consuming for the practitioner because sitting and explaining the lifestyle changes that need to be done for the practitioner to explain to the patient can be very time-consuming. Gene profiling, on the other hand, adds to the cost. It is affordable nowadays, but not affordable for everybody. The big advantage, I think, of gene profiling is it gives you a scientific approach. And I think with some people, when you offer them the science of what's really happening in their body, it may improve the patient compliance, because the biggest problem with the lifestyle issues is getting the patient compliance to make changes that they really don't want to do, because really we don't want to give up our glass of wine, and we don't want to give up our Rolo or our chocolate or whatever. So sometimes looking at the genes, their specific genes, can help that. It also gives the practitioner a more targeted approach for treatment. So if, for example, you are flooded with so many variables that need to be addressed when you're addressing lifestyle, looking at gene profiling can sometimes give you just a direction in which to start with, so you can walk the patient through lifestyle issues, starting with the most high-risk ones. And, of course, gene profiling answers some of the why questions. Why did this person get cancer versus somebody in the same family who maybe didn't? So just to recap on genetics, for those who've forgotten about it because they did it years ago. So the human genome has got around about 24,000 gene sequences. So a gene sequence is a series of nucleotides in a particular pattern, and this pattern codes for our proteins. So we, for example, might have, we've actually got more than 100,000 different proteins, and although we've got only 24,000 different gene sequences, those gene sequences are not specific to only one protein. In actual fact, they might cover several proteins, which is quite interesting from a genetic perspective. But now, within that gene sequence made up of all these little nucleotides, which, let's say for the purpose of this explanation, one could think of like beads, there might be one bead in that protein sequence that's wrong. In that situation, we call it a SNP. It's a single nucleotide polymorphism. And what happens is, let's say, for example, that gene sequence is coding for an enzyme. And of course, your enzymes, as you know, are the workhorses in our body. And what will happen, it'll affect the efficacy of enzymes. It also affects cytokines and our metabolic processes. Now, what is wonderful about knowing about our SNPs is that SNPs can be influenced by the foods that we eat, by the hormones that we are exposed to, exercise, our attitude, our stress responses. And these are all factors that we as individuals we can influence them ourselves. We can actually take control of those. So what we can do by taking control of those is we can minimize the negative influence of our inherited gene SNPs, because of course the genes cannot be changed, but whether or not a gene is expressed or whether it's hidden can be changed. So we can minimize the negative and we can encourage the positive. So what happens when we profile genes is we profile the gene SNPs. We have a look at the gene SNPs, and the ones that we profile in South Africa, we're looking at the ones that have been researched and have the greatest influence on health. Obviously, there are actually thousands of SNPs, and we don't profile thousands of SNPs. So they've really cherry-picked the ones that seem to be clinically of greatest influence. And then as a practitioner, one would look at the gene profile and we would couple it with a comprehensive case history, what the patient eats that they shouldn't, what they don't eat that they should, their lab results, and we can develop an informed plan of action that's maybe a more systematic plan of action if we're looking at it from a genetic perspective. So if you look at SNPs, if you would say, for example, this little diagram above is a series of nucleotides, and let's say one of those nucleotides is not right. I mean, we might have a gene that's 2,000 nucleotides wrong. Sorry, 2,000 nucleotides long, and one nucleotide might be wrong. And that's where the SNP comes in. So they're variations. They're not really mutations so much as variations. And because they're variations, they affect the function of that particular enzyme. Now, when you're addressing genes, you look at two factors. You look at penetrance of the gene and you look at expressivity of the gene. So penetrance refers to the number of people that have inherited a particular gene variant or SNP who actually exhibit the signs and symptoms of that genetic disorder. And what happens is the statistical occurrence, so the penetrance actually increases as we age, because obviously as we age, our exposure to influences gets more intense as we get older. The other thing to bear in mind is that other genes have an effect on the penetrance. And just because you've got a gene doesn't mean that you're necessarily going to have a manifestation of that particular condition, which is great for us all to know. As far as expressivity is concerned, if you're looking at the people who've got the gene, they may express the gene in differing degrees. So some people may have the gene and they may express the gene. In other words, they may get very mild signs and symptoms, and somebody else may really have very life-threatening signs and symptoms. And usually that's got to do with other gene SNPs that that person has inherited that make that one gene SNP worse. So it's the mix of all the gene SNPs. Of course, lifestyle plays a big role in whether or not a gene SNP that you inherit is going to express. And again, as we get older, the expressivity increases as we get older. So we're more likely to express a gene SNP that might be hidden and dormant when we're young. And as we get older, as we get 60, 70, and 80, that expressivity obviously can multiply as we get older. But for the lucky ones, the gene SNPs can be completely asymptomatic. And we don't even know we have them. Now, certain diseases are associated with one particular gene. So something like Huntington's, for example. And Huntington's is a dominant gene. So it only takes one parent who happens to have the Huntington's gene for that gene to be expressed in the child. But even with Huntington's, there can be degrees of Huntington's. Most diseases need the presence of several gene sequences or gene SNPs to manifest, and most diseases need other factors, in other words, lifestyle factors, to manifest that gene. And of course, that is the science of epigenetics. So epigenetics looks at the lifestyle factors that influence our gene inheritance. So some collections of gene sequences increase your susceptibility to some diseases, and some gene SNPs influence your susceptibility, in other words, your success or the harm that happens to you of some drugs. And when you're dealing with cancer, this is quite important if, for example, the patient is going to go on chemotherapy, because they may inherit certain gene SNPs that mean for them chemotherapy is very deleterious to them, whereas somebody else may, for example, have very strong detoxification genes, and chemotherapy doesn't really seem to impact them too much. So what we say when we're looking at genes, we say that the genetics loads the gun, but it's actually the environment or the lifestyle that pulls the trigger. So what we have to do, we have to either for ourselves or for the patients that we're treating, we need to guide them down a path that's going to make sure that regardless of what genes they've inherited, nothing is going to be pulling the trigger. So knowledge about SNPs, just quick overview. So SNPs are small variations in the gene sequence. They're going to affect the essential efficacy of enzymes, cytokines, so inflammatory messengers, and any other metabolic processes. They increase your risk of developing a disease. But I just want to say here as well, sometimes people don't have a gene SNP at all, but because they have a lifestyle that is in itself a problem, the fact that they don't have a gene doesn't mean to say that they're not going to develop cancer, because if their lifestyle is particularly bad, then regardless of whether they've got the gene or not, they might still go down that path of developing cancer. And of course, SNPs affect our response to treatment. So we want to never treat the SNP itself or the gene itself. We always want to treat the patient. And as I said at the beginning, when you're looking at a puzzle, gene profiling adds another piece of the puzzle, so one can offer a more comprehensive approach for our patient treatment. And obviously offer a situation where we can, for our patients, we can change the expression of the gene. And from the practitioner perspective, looking at gene sequencing, we can actually decide, okay, well, what is it that I'm actually going to treat as far as this patient is concerned? So our genes can be turned on and off, and we use the term expressed or silenced. If the gene is turned on, it's expressed, and if the gene is silenced, of course, then it's hidden. Now, some genes we want to express. So we want all our tumor-suppressing genes. So, for example, BRCA is a tumor-suppressing gene, and P53 is a tumor-suppressing gene. We want these genes to be expressed. With our oncogenes, we obviously want them to be silent. So it's not really a matter of we want to just express every single gene. We obviously don't want to do that. So how might gene SNP information help you go about treating your patient? So let's go into that. So gene profiling is very useful in addressing methylation status. And because I think methylation is not really a term that is taught in medical school, I will address that in a little bit more detail now. It looks at oxidation capacity, your detox capacity, which is a little bit of a no-brainer, you know, Erin Brockovich type thing, where if we're living in the soup of toxins, we obviously want our body to be able to detox as much as we possibly can. And if, for example, we have poor detoxification, then we don't want to load our body with other toxins like smoking and alcohol and all of those toxins that our body now has to deal with, as well as the toxins that we are not able to deal with. Inflammation is a big one, and vitamin D accessibility. There are obviously more, but you know what, this talk is only an hour, so we'll stick with those ones. So in the cellular and the metabolic response, we're looking at addressing inflammation, oxidative stress, hormone detoxification. All of these we address in gene profiling. Immune dysregulation, not so much. It's important, unfortunately, but it's not really addressed so much in the gene profiling. Metabolic dysregulation, we address. Mitochondrial cytopathies, also not so much, which is a pity. That's probably still to come, because gene profiling that's accessible for practitioners now and for patients is really, you know, it's still in its infancy. High iron risk, detox capacity, general detox capacity, methylation imbalances, our ability to manage our own psychological stress, and our vitamin D status. All of these are addressed in methylation, at least in gene profiling. So epigenetics, as I said, epigenetics looks at our lifestyle and how that influences what genes are expressed. Epigenetics affects what genes we turn on and off, and our gene expression itself is influenced by methylation, the methylation process. So we can have gene SNPs that slow down our methylation, And unfortunately, methylation itself is a process that is influenced by gene SNPs. So it's a little bit of a double whammy with regard to that. And methylation plays a big role in whether or not one is at high risk for developing cancer. So what happens if, for example, a risky gene is methylated? So if we've got good methylation capacity, methylation basically silences the risky gene, so that gene remains unexpressed. And in South Africa, addressing methylation in gene profiling is really the best way we can see it. So generally, when I look at this, I say to people, have you ever wondered how it is that your eye, given the fact that every single cell in your body contains your whole genome, how does your eye know that it needs to be an eye and not a liver, for example? And methylation is what turns an eye into an eye and a liver into a liver. And basically what happens with methylation, it's a carbon with 3 hydrogens attached to it, and they work like pins. So basically what they do is that they pin our genetic material to the histone. So they protect our genetic material. And when it's time for a gene to express, in other words, a gene to be read to make a protein, for example, the methyl group is pulled off that histone, it's pulled off the gene, and the gene is now able to show itself. And then, of course, in showing itself, the RNA can then come in and read it, and then the RNA goes out of the cell, and it can go to the ribosome, and it can actually make the protein. So if we're looking at our genetic material, it's our methylation that actually keeps our genes hidden. And the demethylation actually allows our genes to be expressed. So again, what we want is we want methyl groups to keep our oncogenes hidden, and we want a demethylation to allow our tumor suppressing genes to be expressed. So there's a fine balance between methylating and demethylating. Just as my little joke, this is methylation. So this took me months to understand. So obviously I don't expect you in the short lecture to understand this. So you can see methylation is quite a comprehensive and complex process, but it is understandable. So really with methylation is the act of giving a methyl group, which as I said is a carbon with 3 hydrogens attached to it, to another compound. And when a methyl group is attached to the compound, it changes the chemical structure of that compound and it makes it something else. So it does require enzymes and it does require cofactors, but methylation affects your gene expression, as I've mentioned. It affects your hormone detoxification. So for example, if our body is needing to detoxify estrogen, estrogen is not able to be detoxified as estrogen. It actually needs to go through, and I will address toxins and I'll explain it then, but it actually needs a methyl group. So a methyl group needs to attach to estrogen in order for the body to neutralize it and to detoxify. It also affects the receptor sensitivity to hormones. So again, if you're looking at the hormone sensitive cancers, methylation affects that. Methylation, a methyl group detoxifies histamine. So histamine, of course, affects cancer proliferation. It affects angiogenesis, immunosuppression, and inflammation. So histamine detoxification is important. Our methylation affects our stress management. And if stress is a big player, in other words, our cortisol response is a big player in our risks of developing cancer, then methylation is important. So sleep is assisted by methylation because, for example, serotonin, methylated serotonin becomes melatonin. And of course, we need that for sleep. And just our peace of mind and how we manage our stress and our neurotransmitter health has a very close association with how our methylation processes work. So in compounds in the body, uracil, which is in RNA, and a methyl group makes thiamine, which is in DNA. Homocysteine and a methyl group makes methionine. Noradrenaline and a methyl group makes adrenaline. Serotonin, vitamin B5, and a methyl group makes melatonin. So you can just see, I mean, I've just mentioned a few, there are lots of them, but this is just a few examples of methylated compounds. And the disease associated with dysfunctional methylation, I've just highlighted the ones that might be associated with cancers, but there are lots and lots of diseases that are associated with poor methylation. And really in gene profiling, we focus a lot on the gene SNPs that are involved in the methylation process. So let me just go back here. So if, for example, you're looking at viral infections, here you can see that viral infections account for 15 to 20% of the environmental factors that affect whether or not we're going to get cancer. So methylation is going to affect that. So just in the methylation process, the gene SNPs that we look at are MTHFR. That's a very common one. It's very well researched. The other ones, MTR COMT is also very well researched. That not only addresses our methylation of estrogen and our detoxification of estrogen, but it also helps our body to detoxify adrenaline. So people who have a SNP in this catechol-O-methyltransferase, which is COMT, they struggle to get rid of adrenaline. Of course, then they're going to struggle to manage their stress. And then the knock-on effect is if they're not managing their stress, then that can also, with other factors, influence whether or not they're at risk of developing cancer. And the VDRs to vitamin D, we all know through the COVID era as well, we all know how important vitamin D is. And we can inherit SNPs that make our VDR, our vitamin D receptors, not very receptive to vitamin D. And then obviously we need to expose a lot more aggressively the supplementation or the exposure to vitamin D. So let's look at breast cancer in a little bit more detail. You know, for breast cancer, the prognosis is the same as it was 50 years ago. So really, it seems that people are not getting on top of addressing breast cancer. So looking at preventing breast cancer from the start is obviously first prize, because once one develops breast cancer, it's really that much harder to overcome that. The BRCA genes, so BRCA1 and BRCA2, as I said, they're tumor suppressors. So what tumor suppressors do, they respond to DNA damage. So they help the body to repair any damaged DNA. But mutations of these genes, so they've been linked to development of breast and ovarian cancer, but not every woman who inherits the BRCA genes is necessarily going to go on and develop breast or ovarian cancer. There are lots of other factors that play a role. And in fact, only about 3% of women who've got breast cancer have the BRCA gene. So for the rest of them, that's 97%. It's all related. Again, we're getting back to the lifestyle issue. So lots of genes are involved. So even finding out whether or not you've got BRCA, this is one of the genes that I think, for example, is a little bit of a waste of money. I think sometimes if one goes to an oncologist, they might send off to see whether one's got BRCA, but whether they find out whether you have it or whether you don't, their treatment process tends to remain the same. So as an isolated gene, learning about it is not as helpful as learning about other genes. Stress, as I mentioned, is a big player in developing breast cancer. And as I said before, COMT, gene SNP catechol-O-methyltransferase, is an enzyme that helps us to detoxify estrogen. So any of the estrogen-associated cancers, it helps to detoxify that. So if you have the COMT genes and you inherit, for example, from both parents, in other words, you are homozygous. If you inherit from one parent, it's called heterozygous. Homozygous is from both parents. So if you inherit the COMT gene from both parents, it makes the enzyme activity very slow. So your detoxification of estrogen is very slow. So the estrogen is held in the body for longer. Similarly, with adrenaline. So if you have the COMT gene, your body doesn't clear adrenaline very easily. So your stress levels tend to be more reactive because your body's holding onto the adrenaline. So if you, for example, have got COMT, and you might find out if you're young and you do a gene profile and you find out you've got COMT, then you can start addressing it to help to support COMT so it speeds up a little bit so that you can detoxify your estrogen and your adrenaline, obviously that much better. SALT is another one that's associated with breast cancer. Basically, SALT is an enzyme that, again, in the detoxification pathway, just like the body might need a methyl group to attach to the compound to detoxify it, A sulfur group works the same way. So sometimes the body needs a sulfur group to detoxify, and estrogen is also detoxified using the sulfur groups. And if you've got the salt gene SNP, it means your detoxification via the sulfur groups is not as effective as it should be. So this was a study that was done where they looked at, it was published in the Journal of Gynecological Oncology, and they looked at the combined effect of CYP1B1, which I'll talk about in detoxification, COMT, the GSTs, which happen to be gene SNPs that address glutathione, your manganese superoxide dismutase, which is a gene SNP that addresses how your body deals with free radicals. The combination of these gene SNPs, if a woman has these, or a man, because of course, cancer happens, breast cancer happens with men too, then their risk of developing breast cancer is obviously that much more. So in a situation where, for example, somebody does a gene profile and they look at these, they can start addressing these from a lifestyle perspective at an early stage before it develops into any kind of a cancer. So detox, I've touched on detox. I just want to elaborate a little bit on that. So you may or may not know, but in actual fact, your detoxification in the liver is in 2 phases. So in phase 1, detoxification of the liver, what happens is the substrate. So anything that needs to go through the liver, we call the substrate. So it might be a toxin, so maybe a pesticide, persistent organic pollutant. It might be a hormone. So it needs to be detoxified through the liver. It goes into phase 1. In phase 1, an enzyme called a P450, we call them CYPs, is acted on. So it acts on that substrate and it catalyzes that substrate and it makes it more water soluble. And that metabolite then goes from phase 1 through the action of the CYPs, the P450s, into phase 2 in the liver. And in phase 2, a compound is joined to it. So in phase 2, that's when the methylation groups will join to the metabolite, or an acetyl group or a sulfur group. These join to the metabolite and then the body's able to excrete them. The body's not able to excrete directly from phase 1. It has to be acted on by the enzyme, and then it goes to phase 2, and the conjugation has to happen in phase 2. And ideally what you want is you want your phase 1 and your phase 2 in your liver to be working at the same rate. So for example, I'm not very pro detoxes where you, for example, go out and you just go on a water detox, or you go on a grape cure or something like that, because what happens with those detoxes is that they amplify phase 1, but if you don't address phase 2 and pull it up to the same level, then you've got all these metabolites, and sometimes the metabolites are more carcinogenic than the original compound. So for example, estrogen, when estrogen is metabolized, some of the metabolites of estrogen, the 4-hydroxyestrone, the 16-alpha, are considered to be carcinogenic. So what happens then is phase 1 is upregulated, and these carcinogenic metabolites then just go cycle around and around in the body because they're not able to push through to phase 2, where the body can excrete them. So in gene profiling, we look at the detoxification process, and I mentioned the CYP1B1 here in the detoxification process is very important, especially when you're dealing with hormone detoxification. But all of these gene SNPs are involved in detoxification. And again, if we have a look at those, and we can see, for example, that a patient may have absent genes for some of the glutathione gene sequences, then in a situation like that, you need to address the detoxification long before it reaches the point where glutathione has to act on it, because the glutathione, of course, is not very effective. Vitamin D is so important in terms of addressing cancer. So the vitamin D influence, studies have shown that low vitamin D, so under 20 nanograms per milliliter, correlates with increased tumor size. The overall survival rate is better if the vitamin D levels are greater than 30 nanograms per milliliter. In menopausal women, the relapse rate is higher if their vitamin D is low. The risk of distance metastasis is greater with a low vitamin D, and at higher levels, there is increased reduction in mortality, so all really important. In a study that was done in 2012 in Belgium, they looked at women with low vitamin D levels had bigger tumors, they had increased risk of death, and in postmenopausal women with higher vitamin D levels, they were most likely to have the smallest tumors and the lowest chance of death. And addressing vitamin D is such an easy thing to address. You know, we live in a country where there's sunshine pretty much all the time. And even if one doesn't want to expose ourselves to sunshine, or you can't because your job doesn't allow you to, we've got vitamin D3 supplements that are they're cheap and they're accessible. Another study showed that women with low vitamin D levels were almost twice as likely to have the cancer metastasize. And women with low vitamin D were more likely to, they died during the study in actual fact. So women with low vitamin D levels, they had worse tumors than women with high vitamin D levels. So to me, to address whether or not one does a gene profile, because if you do a gene profile, you can see whether the vitamin D receptors, the VDRs, so if you look here, they look at the VDRs, you can see whether the VDRs have got any gene SNPs in them. And if you look at VDRs and you see, okay, this particular patient has got VDRs with gene SNPs, then you know you need to be much more aggressive in your supplementation with VDRs. Similarly, with inflammation. So if you, for example, are looking at a gene profile and you see that a patient like this particular one has got a lot of SNPs in inflammation and immunity, then with them, what would happen is that they would need to have all the inflammatory triggers addressed. So anything that could feed into an increased inflammatory response in the body, you would need to address those. So all the obvious ones, you know, infections, obesity is very inflammatory. Poor diet, so sensitivity to gluten and dairy, they create inflammation in the body. Allergens, toxins, heavy metals, all of these things that we know create inflammation, but we know they do, and yet we don't address it when we're looking at treating cancers or from a risk perspective or from a recovery perspective. And yet all of these, well, these are sometimes difficult ones for patient compliance because they really are lifestyle ones, you know, and patients necessarily, they don't want to give up their gluten and their dairy. But again, with a gene profile where you can show them, this is you, these are what your genes look like, and this is what we need to do, their patient compliance can possibly be that much better. Excess weight and cancer, we all know that excess weight increases one's risks of developing cancer, not only because excess weight holds estrogen, but excess weight really, increases the risks of several non-communicable diseases. And weight gain accounts for about 20% of all cancer cases in some way. And being overweight almost doubles the risk of dying from breast cancer. But in terms of cancer recurrence, this is a bit of a double whammy too, because underweight women, especially if they've had cancer before and they've got the associated cachexia that goes with it, underweight women then have an increased risk of developing a breast cancer recurrent. And the very sad news is that there's no risk-free level of alcohol. And in actual fact, your risk of breast cancer increases by 30% if you're drinking more than 3 glasses of wine a day, which is very sad when you're trying to deal with stress and you're using alcohol as a way of managing your stress. So other gene SNPs, the GSTs, these ones I've mentioned already, these are the ones that are involved in the production of glutathione. These are also players in cancer risk and cancer recovery. Your manganese superoxide dismutase, this one looks at how your body handles free radicals, particularly free radicals around the mitochondria. So if one wants to keep one's mitochondria in good health, this is a gene SNP to address if you've, or rather you need to address free radicals if you happen to have inherited this particular gene SNP. Now, if, for example, you cannot do a gene test, because not everybody can afford it, I'll talk about price just now, but then your clinical evaluations, you can look at your blood tests, and obviously there are lots of blood tests, but just for the purpose of this talk, I'm looking at your homocysteine, addressing homocysteine. Homocysteine is very, very seldom measured, and I don't actually know why, because homocysteine is a player in heart disease, it's a player in dementia and Alzheimer's, and it's a player in cancer. So you want to keep your homocysteine levels at between 7 and, let's say, between 6 and 8. And homocysteine is directly associated with increased risk of colorectal, breast, and prostate cancer. Your inflammatory markers, high sensitivity C-reactive protein is the easiest one to measure. Unfortunately, it's not very comprehensive. It's helpful, but not very comprehensive. Sorry, I just want to go back to homocysteine. I use homocysteine as well as a cheat to see how well a patient is methylating. It's not a perfect cheat, but it is, in the absence of being able to do a gene profile, I will sometimes use the homocysteine to see, because if the homocysteine levels are high, usually the patient's not methylating properly. Ferritin is another such an easy test to do, and it's not very expensive. Iron overload increases inflammation, so you want to make sure your ferritin is not too high. And men and postmenopausal women, the ferritin creeps up. And again, ferritin or iron overload is easy to get rid of. You just go and donate blood. So it's one of those ones that easy to test, reasonable cost, and you can actually just go and donate blood. Fibrinogen, because fibrinogen actually coats cancer cells, so it creates that camouflage, and vitamin D, which I've addressed sort of in great detail. What is a gene test not? So a gene test isn't a definitive diagnosis of any disease. It's not a guarantee against a disease. It's a trend. It allows us to look a little bit deeper. It's another piece in the puzzle. It's not a paternity test. At least these ones are not paternity tests. It does not test for all diseases. And it is not a simple consult. It's not one of those situations where you can have a quick consult with a patient when you're working with gene profiling. It takes time to profile the genes, and it takes time to address those with the patient. Of course, it's for the individual, so the gene profile is meant to look at that particular individual, and it's important that we address the patient and not the SNP. And with gene profiling, I think to explain to the patient that if they've got gene SNPs, this is very empowering. It doesn't mean that they can throw up their hands and think, okay, well, you know what, fate is going to get me and I'm going to get cancer. Not at all. Because with gene profiling, you can actually see what you need to target and what you can address. And all of these you can address whether or not you hide them or whether you express them through lifestyle factors. Unfortunately, it's not paid for by the medical aids, which is a pity. So from a cost perspective, now in South Africa, there are 3 gene companies in South Africa, and they all test much the same profile of gene SNPs. Some are more comprehensive in certain sections than others, and sometimes the gene companies change them. I'm not affiliated with any of the particular gene companies. I've worked with 2 of them, and there's one that I just like better than the other because I like the way they lay out their reports. The cost to the patient is between 4,000 and 5,000 for the patient. The practitioner obviously gets a practitioner rate. So the gene companies will give the practitioner rate, and then the practitioner will obviously charge the patient rate. But the gene profiling does need interpretation. You can't just give the patient the report and think they're going to know what's going on. I mean, they could turn the report upside down and it would make as much sense to them. And gene testing is not for everybody. Not everybody has got that extra bit of money. And I think if people are not going to make the lifestyle changes, then to spend an extra 4,000 to 5,000 Rand is maybe not for them. So it is for specific people. So this, for example, is one of the gene profiles that I like the way that it's laid out. They've laid it out in a way that a red means it's homozygous. In other words, you've inherited it from both parents. Yellow, you've inherited it from one parent, and green means you're non-variant, you haven't inherited it at all. But again, just because it's green does not mean you can rest on your laurels and you can have a lifestyle that is going to fundamentally be deleterious to your health just because you don't have that particular gene SNP. These gene SNPs also measure issues like your risks of Alzheimer's and those sort of issues as well. So if any of you have any questions that they're not addressed now, then you're welcome to contact me. Otherwise, if there are any questions, then I'm very happy to answer now.
Thank you very much, Jules. Can you hear me?
Yes, I can hear you.
I find the whole genetic sort of the way genes has now influenced medicine, it's actually quite fascinating. One quick question. Did you say medical aids do pay
No, they
for
don't.
things?
They don't, unfortunately. So if, for example, strangely, they don't pay for these gene profiles, they will pay, for example, if you are with an oncologist and they send you for a BRCA gene or some of those, they will pay for some of those. But in speaking to patients who've had those specific genes done, it hasn't really made a difference with the oncologist as to their method of treatment. So I'm not sure how helpful that is, but unfortunately, these more broad gene profiles, they don't pay for.
Okay, that's that's great. It obviously becomes an issue, especially with cancer patients, because the diagnostics become very
So
expensive,
expensive.
and
Yeah, they're
the
so expensive.
treatment also
Mm.
becomes very expensive. But I would assume that if you did have gene profiling done and you realize that you were slightly high risk, you'd be more likely to alter your lifestyle if you saw your genetics. Do you find that?
Yeah. Yes, definitely. The other thing to bear in mind is that sometimes it's not a bad thing, because genes are immutable. Obviously, they never change. So it's not a bad thing if one is in a situation when you're younger to have a gene profile done, and then when you're younger, before all the issues hit you, when your body struggles when you're older, is to have a look at your genes when you're younger, because then for example, especially if you've got a history. So, for example, let's say your mother's had breast cancer and your grandmother and so on and so forth, then it's maybe worth having a little look where over a period you might just put a little bit of money aside every single month so that you can have a gene profile done. But yes, I do know that the cost, it is just an additional cost in probably a huge pit, black hole where all the money pours down.
Yeah, because cancer is
So
definitely better
expensive.
avoided. Yeah.
Yeah, yeah.
But I'm just going through the chat and seeing if there are any other questions. I think for a lot of us in Southern Africa, it's available to very few. So I think a lot of the lifestyle changes that we discussed at the Vic Falls conference in terms of um, assuming that you you may be prone to cancer and keeping your
Mm,
life as toxin free as possible are probably quite important. And then
yes,
obviously keeping your insulin levels down
yes.
as much as
Gosh.
possible
Mm.
is another whole subject all on its
That's a
own.
whole subject. That's a whole subject on its own. Definitely, because at the end of the day, to err on the side of caution and say to the patient, you know what, these lifestyle, we know that these lifestyle habits are going to give you a better chance. Go that route. It's just a mental change, really. To start making some changes, and one can use certain questionnaires. So, for example, I've got questionnaires to try and work out whether somebody has low methylation or high methylation. So you can do it with questionnaires. If somebody's particularly resistant and they need more science, then to go down the gene profiling route can be helpful for those patients if they've got the
Mhm.
money, of course.
Yes. So I have a few patients on the Salal homocysteine lowering um, formulas.
Yes, yes.
For patients who are under methylators, what do you suggest in terms of B12? Do you inject B12? Do you give extra
No,
B12?
I
Or would
actually the inject yeah, so the injected B12 is cyanocobalamin. So
Mhm.
it's not a meth, it doesn't come, well, you can get a methylated form, but again, it's very, very expensive. So the compounding pharmacies will offer a methylated B12, which one can use as an injection or in a drip, but you can get methylated B12 as a liquid. It's the Now range has a methylated B12. So I will tend to go that route sooner than I will go for the readily available cyanocobalamin B12. Again,
Okay.
because if, for example, somebody's got the MTRR gene SNP, they're not going to be able to manage that cyanocobalamin. It's going to be useless in their body, in which case they need the methylated form right up front. And then they can use those methyl groups either in their homocysteine cycles or in where they might need detoxification. They can use those methyl groups for that. But just
Right.
something to just bear in mind, the methylated form, because, for example, adrenaline, so noradrenaline to become adrenaline, it needs to be methylated. Sometimes what happens is that when you give a patient a methylated B, they get very wired. So one always has to discuss with the patient that they might notice that they're very reactive, or a sense of anxiety increases, because now what's happening, they might have been very low on methyl groups, which was great in some ways because they weren't methylating to adrenaline. Now you give them methyl groups, and now all of a sudden the noradrenaline is able to methylate to adrenaline, and all of a sudden their anxiety just goes through the roof. So the other factors to consider when you're just giving methyl groups, to not, you might be resolving one issue, but you might be triggering another issue because of the excess, the methyl groups that are now available.
Okay. Thank you for that. Another question in the chat. I've always wanted to know whether food preservatives play a role
Yes, that's
in
such a good
methylation
question.
reactions in our bodies and eventually in the emergence of cancers.
Yeah, so that is such a good question, because when it comes to food preparation, what goes into our food, the additives, so let me just get this right in my mind. The food companies are required to list the additives, but they are not required to list the process that they went through in actually making the food. So, for example, let's say they were using a sunflower oil to create something. And what they needed to do with the sunflower oil, because it's repeated and they're using it again and again, they needed to deodorize it, and they needed to strain it, and they needed to degum it. Those agents that are used in that process, they are not required by law to list onto the package insert. So what we are actually exposed, what we are told we're exposed to, and what we are actually exposed to, they are poles apart. So somebody, normally what would happen is that our detoxification capacity is going to play a role in whether or not we're able to detoxify the chemicals that they add in those. So yes, they do play a role. And this is why, if you've got a little garden and you can start growing your own organic food in the little garden, it's really the way to do it. I keep talking to myself and saying, this is what I need to do. I haven't done it yet because I don't want to be a farmer, but it really is worth doing.
Great. One other question, I'm not sure if you'll be able to answer. Thanks very much for the very informative presentation on genetics. Is it true there's a gene in some people that protects them from being infected with the HIV virus?
I
Well,
don't
I don't
know.
know
I've
the
not
answer.
heard that. No, I don't know the answer to that. I'm sorry. From everything I know about genes, my answer to that would be no. I don't think so. That doesn't make sense to me. But
Mm,
I can't answer that definitively. I don't know,
mm.
Jackie, do you think, does that make sense to you?
No, I don't. It wouldn't make sense. That
Your
wouldn't make
exposure,
sense to me.
yeah, the exposure to HIV, and whether or not you catch HIV, it's so multi-layered that to just attribute one gene to protection, I think would be maybe too short-sighted.
Mm. Yes, it's so multifactorial. Well, thank you, Jules. I think that's all the
This,
questions for now.
Laurel's raised a hand. There's somebody who's raised a hand. Laurel's. I
Oh,
don't know
there
whether you
we go.
answered the.
All right. Thank you, Jules. Thank you, Jacqueline. So I'm really excited to be part of this conversation. I'm coming from a diagnostic perspective. I'm a medical laboratory scientist, and this was quite an eye opener. So we have embarked on a journey of trying to explore these tests and offering them locally for our lab in Zimbabwe, Simas Med Labs. So I was hearing that there's something that I just picked on, that you preferred the structure of the report for a certain lab, for a
Yes.
certain partner that offers that. That is quite crucial. So I just wanted to know what are the aspects, for example, some of the things like turnaround time for the results that may be issues of concern for you, as the clinician who requests these tests and needs these results?
Okay, so yes, you're right. The layout it really helps. So that one layout where everything is sort of done in those colors, it's just so quick and easy. So that particular company happens to be GeneWay, and I personally just find their layout very easy. So if you contact me, what I'll do is that I'll send you sort of like a dummy sample of the various layouts, and you can see how other companies have done it. Because from a practitioner perspective, it is just easier to look at some. The turnaround time varies. So the turnaround time at the beginning, when the company started, the turnaround time was longer, because obviously they were waiting for several runs, and they would wait for several patients before they did runs on this. But now it's much faster. So, but even then, the turnaround time is still, it's round about 10 days to 2 weeks. That's the general turnaround time.
All right, thank you so much, Juice. I'll definitely be in touch.
That's fine. That's no problem at all.
So two last
It's good
questions.
to know you're doing something in Zimbabwe. That's fantastic. The more, the better.
Yeah, definitely. So exciting.
And two questions. One is there any connection with the microbiome and cancer risk?
Yes, there is. Because I mean, if you think about the microbiome, they're putting out certainly more genetic material than we hold, but also because the microbiome influences our response to food. So just one example, let's say, for example, the microbiome, you tend to be eating very high inflammatory foods, or you're eating foods that are very high in carbs. You're going to develop a microbiome that's particularly, it's pro-inflammatory. And of course, again, we're back to the bedrock of cancer, which is that pro-inflammatory, versus developing a microbiome that's not inflammatory, that actually keeps the body cool. So in terms of one of the influences, yes, I would say the microbiome is a player.
And I would say the same for seed oils as well.
Yes, indeed. Yeah, and very much so. I would say so too. And the thing with seed oils too is that we think we have this perception that, when we've got our sunflower seeds, a seed oil, they've got all these lovely sunflower seeds, and what they do is they press out the seed oil, and then we get the result, and it's all beautiful. And it's not like that at all. The process of creating these seed oils is disgusting. So, and all of those chemicals that are happening behind the scene, we're feeding those into our body if we're using seed oils. So, I agree with you, Jackie. I think seed oils play a big role.
Great. Well, I'm aware of time, and I'm aware that our team at the campus are going to need to for speaking to us on this very important topic. And thank you for really demonstrating how genetics can be used in a more sensible way in cancer.
Well, fantastic. Thank you. I enjoyed it. Thanks very much for listening.
Thank you, everyone. Good night.
Enjoy your evening. Night, night.